Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, I am going to discussing about the generative adversarial network and how can you generate the human faces using GANs. So बिना किसी डर के हर हर महादेव बल के start करते tutorial. In order to building on GAN architecture and also the generate some fake images, we're going to using a dataset from the Kaggle that's called the celebrity dataset. And inside this dataset, it having the images of the celebrity. Now using those images, we are going to generating the fake images for the celebrity. You can also use the GANs for the image to image translation and also for the data argumentations. So without wasting your time, let's go on my Jupyter notebook. So this is the folder in my directory. If I go inside here again, and you can see here, this is the images of the celebrity. Now using those images, you're going to create one GAN architecture and try to generate some fake images. In order to building our GANs architectures to generate some fake images, we're going to using here Jupyter Notebook. You can also use here the VS Code, PyCharm or Google Colab itself. So now I am simply going to import here the necessary library which one is required in order to building one GAN architecture. So let's say I'm first going to import here NumPy as NP. Then I'm going to import here the TensorFlow. Let's import TensorFlow as TF. And make sure you need to install this library in your system. Otherwise, you can also use the Google Colab. Okay. So let's say I'm going to import here the matplotlib.pyplot as plt. Then also I'm going to import here the OS, import OS. So let's shift enter, or you can also using here the run button from here in order to loading this file. Now what I'm going to do, I am simply going to load the file inside my directory. I mean load the images from my directory. If I go inside my directory, and you can see here, this is my image align, and inside this image align, it have another folder that's called image align. And again, inside this image align, I have the images of the celebrity. Okay. So now what I can do, I am simply going to give here my directory path. So let's say directory, and I'm going to make it, let's say image. It's called the align. It's called celebrity or celebra. Okay. So this is my path of my image directory. Now what I can do, I am simply going to getting all the images from my directory. So let's say get all images from directory. Okay. So one more thing, one more disclaimer for that. If you are following this tutorial, just follow this from the end, because it's just not for the projects. Just you are just coming from this tutorial and searching for the projects. That's not for you. It's just for the person who are interested to learn the GANs. Okay. So now what I can do, I'm simply going to using here tf.preprocessing.image dataset, because this is one inside one folder. Now inside this folder, I have my another folder. So now what I can do, I simply going to stack the file from here. So for that, what I can do, I am simply using the tf.keras.preprocessing. You can also use the tab button here in order to do the auto suggestions. Then I'm going to use here the image. So you can see here image data from the directory. Now inside that, I am going to pass here my directory. Let's call directory. So directory equal to directory. Okay, this is my directory. Then what I can do, I simply going to give here my color modes. So let's give here color mode. So color mode is nothing but my RGB, red, green, and the blue channel. Then what I can do, I am simply going to give here my batch size. So batch size, let's give here 128 based on my PC requirement. One more thing, if you have the low end of PC, so don't do this program. Better you can use here the Google Colab. Otherwise, maybe your PC having some problem, maybe crash. Okay. So I'm going to give here my image size. So let's say image size. So this is the complete theoretical based project. I'm going to making this GAN architecture from this course. Okay. So now I'm simply going to give here my size of that. Let's go 32 cross 32. Just I'm going to make all the images size should be 32 cross 32. So let's give here level mode. Level mode, it's 9. Okay. We don't need to load the level mode here. Okay. Because this is not a TF or DF types of projects. Then I'm going to make the shuffle so that it can shuffling the data. Let's make the shuffle should be true. Shuffle should be true. Then I'm simply going to make here one seed so that it's not changing how you need to run in this shell again and again. Okay. So now what I can do, I am simply going to define it inside one folder that's called the data set. Okay. Simple data set. Okay. Data set. So if you enjoy this video, so please like here and share with your friends. Okay. Now what I can do, I am simply going to normalize the data. So let's call normalize the data. Okay, that's it, normalize the data. That's it. So in order to normalize our data, so what we can do, see one more thing just here. our images minimum value is nothing but called 0, and the maximum value is nothing but 2255. So when you're trying to normalize our data in 0 to 1, you need to divide with the maximum number value. Now it having so many images, so we can use the lambda function. Simply you can use the lambda function. So for that we need to also map our data. So let's go data set dot map, and inside this map I'm going to use here lambda function. Lambda is nothing but one anonymous type of functions. Which one? It can do the things in magic, just like a magics. So you can see here inside this x, I'm going to divide all of them is a 255. Let's make it floating point 2550. That's it. Now let's put it inside the dataset folder. Dataset. That's it. Okay. So our data set is normalizes syntax error. So okay, lambda. Okay, I need to make it like that. Okay, divide by 255 sat.map lambda. Okay, lambda. Okay, that's it. Syntax error. Okay, now you can see here it is loading the data set from my directory and try to divide our data set with 255 so that we can normalize our data set. Now let's better we can checking some batch of the images that how the images looks like. So for that we can also import. You can see here it having so many images belonging to one classes, because this is just nothing but one classification tags also. Okay. Okay, when we go deeper, we discuss about the architecture of the GAN, which is quite important, like convolution, the deconvolution, so many tasks. Okay. Now what I can do is simply going to show it in a grid of images. So for that, what I can do, grid of images. So for that, we need to also import here one library that's called mpl toolkits. Okay, toolkits, mpl toolkits dot axis grid. This one axis grid one. I'm going to import here the image grid. Grid aja. Okay, image grid also imported. So let's try to shift enter. Now it's loaded. Now what I can do, I am simply going to iterate to all the value from the dataset folder and try to creating one batch of the images so that you can see the sample of the dataset, so that you can also add it inside your research paper. Okay, so for that I'm going to use here one iterator and pass my data set to the iterator, and let's define it inside one variable called it. Okay, now let's taking on one batch. So for one batch you can be using here the next. You can use here next dot numpy just for checking the batch size of images, batch to batch. I mean how many batch of images it will come in here. Okay, that's a numpy. Convert it to numpy array. Now this is nothing but my one batch. In one batch I have the one images. Okay, just for that. Now what I can do, I am simply going to define my batch. In the one batch, how many images? So let's say 16 images. So let's say I'm going to say that in one batch I have the 16 images. So for that, from the 0 to 16, it is nothing but random, and all the columns, all the things, then all of them. Okay, right? I mean it having the 4 1. I mean number 1, number 2, number 3, number 4. It having the 4 column and the 4 row. This is how you can actually checking for the images. Now inside that I'm going to give here my one batch of the images. Okay, I mean 16 16 16 4 columns. Now what I can do, I am simply going to show the images using the image grid. Let's just show the images. I just going to make it comment here so that you can understand it also easily when you're trying to open the IP1 file, notebook file. Now what I can do, I'm simply going to use my plt.figure so that we can show it easily. And I'm going to give here my fixed size. So let's say fixed size, and fixed size, let's give here 15 comma 15, so that it's quite bigger. Otherwise you can make it, let's make it 10 comma 10. Okay, let's make it 10 comma 10. That's fine. Let's initialize it inside one figure variable. Well, now we're simply going to call our image grid, and inside that I'm going to pass my figure and give here one grid size, and let's the number of rows. How many number of rows can be happening? Number of rows. So number of rows and columns should be 4 comma 4, because it having the 4 columns and 4 rows. We already discussed about that. 4 comma 4. Then simply I am going to pass here my access pad. So access pad chahiye or nahi? Access pad, let's make it 0 now. Okay, let's make it 0 now. Okay, image grid equal to figure, we pass here 1 1 1, and number of rows in the columns is 4 4 4, 4 is to 4. Let's make it inside our variable. Let's call the grid. Simple. Now what I can do, I am simply going to use one zip function so that you can see it easily. Okay, so for that, it having the axis and also the image in zip. You can also use the enumerator also. Okay, because it having the 2, so that's why I need to using here the grid, because I need to also show the grid images and also the image name, I mean images with the axis column. So that's why it's better I can using here the zip functions. Okay, zip method, not function actually. So let's say x dot image. I am sure x is nothing but my axis of the images. Now I am going to pass here my images. Okay, images. Okay, now I'm going to use the plt.show. Okay, plt.show. You can also using here the matplotlib inline so that you don't need to actually using here this one. Okay, one batch is not okay. Batch शायद गलती से यहाँ पर mistake हो गया, गलती से mistake. Okay, let's try it now. Image is not defined. Okay, it's image किधर है? Images. Okay, it should be images. Okay, थोड़ा थोड़ा गलती तो होता है ना, email हो तो गलती होगा. Okay, so now you can see here, this is nothing but the images from my directory. Okay, which one is loaded, and it's also converted into 32 cross 32. So that's why it's quite noisy also. Now what I can do, you can simply using this data set in order to building one GANs architectures. So now let's go on the GAN architecture. What is actually GANs? So GANs is nothing but is called the generative adversarial network. Okay, किधर गया? And network. Okay, so using that you can actually generate some fake images. You can also do the image to image translation. You can also do the data argumentations. Okay, you can also do that just for creating some random data. Now let's say there is a two term that's called the generative or called the generator. Generator, and another one is called the discriminator. Okay, generator and also have the discriminator. Now what is actually generator? Generator is nothing but working for generating the fake images, and discriminator work is try to classify them, which one is the fake images and which one is the real images. That's mean discriminator is nothing but one kind of image classification tag. See one thing, is nothing but one kind of image classification tags. Okay, just for checking which one is the real images and which one is the fake images. And the generator work is to try to creating some fake images from the latent vector. Okay, latent vector, fake images from the latent noise. You can also add the noises. Okay, you can say that also noises. Let's open one picture so that you can see it very details. Okay, so let's see the picture of the GAN, and you can see here just I get on images and see it actually passing here some random noises inside the generator, and this is nothing but one deconvolution network. Again, deconvolution network, and this is the real images, and you can see it passing through the discriminator. Okay, so discriminator work is to classify them which one is a fake and which one is the real images. So again, see generator actually using deconvolution neural network and also using some random noises, or you can say the latent vector, and pass it inside one network and create some faces. Now inside that you can see here real faces pass inside the discriminator, and discriminator is deep convolutional neural network, and it is nothing but one type of classification type of network. Okay, that you do earlier in CNN, and you have to classify them which one is a fake and which one is a real. So this is how the GANs actually work. Now what I can do, first I'm going to creating the discriminator, and after that I'm going to creating the generator. In most of the YouTuber actually do first is creating the generator, and after that it will create the discriminator. But my work is here. First I'm going to creating here the classification model that's called the discriminator, and I'm going to creating the generator. Okay, so this is how one generative adversarial network actually work. So let's try to make it markdown. Let's go on here and do the markdown here. That's it. Now what I can do, first I'm going to creating here the discriminator, then after that I'm going to creating the generator. So for that I'm going to define here on function def discriminator. Okay, discriminator, let's say discriminator model, and then what I'm going to do, I'm simply going to make one model. See one thing here, this is not a sequential model, this is one functional types of model. We are not going to building one sequential model here. So when you're trying to building one GANs projects, make sure you're using the functional API. Okay, not sequential model. Now first thing first, I'm going to creating here my input layer. So for that I need to also import here something. So let's say I'm going to import here, let's say from TensorFlow, okay, not G, TensorFlow dot Keras dot layers. I'm going to importing here the conm2d. So let's say conm2d. So conm2d aja, conm2d. Okay. Then I'm going to importing here. Then I'm going to importing here from TensorFlow dot Keras. I'm going to importing here the model and also going to importing here the input. So which one is nothing but my input? Okay, that's it. Now simply I'm going to using here my conm2d and also the activation function that's called the leaky relu. Okay, it's available inside the layers also. It's layers. Okay, layers conm2d, and we having the leaky relu. So it's leaky relu, not relu here. Okay, see one thing again. One thing. While you're trying to building again one GANs model, don't use here the optimizer. No, sorry, activation function as a relu, using the leaky relu. That's is actually difference between the classification model and also the GANs discriminator. Then we are going to importing here the batch normalization. It's also imported inside the uh, layers. So it's having the batch normalization, BATGS, batch normalizations. Then I'm going to importing here the dropout if it's needed. So okay, you don't need it right now. Okay, for now what I can do is simply going to creating here our input layer, which one taking the input. So for that, what I can do first, I'm going to uh, pass my data inside my input. So that's the input, and inside this input, I'm going to give here my shape. So let's say give here shape. So shape is nothing but my shape of the images, and you can see we already resize our images to the 32 cross 32 with RGB mode. That's the 3 channels. So for that, we're going to passing here my input shape is 32 cross 32 cross 3. Simple as it is. Now you can also give here one name of that so that you can understand that which one is the discriminator network and which one is the generator network. So let's give here one name. So let's say this is nothing but discriminator model or discriminator, you can say network or input. Okay, let's say input, or let's say network, like that. Okay, fine. Now what I can do, I am simply going to pass it inside one variable. Let's call discriminator. That's a disk input, like that. Okay, we're creating our input shape. You can see input shape because inside that we pass here our shape 32 cross 32 cross 3 and give here one name of the discriminator network. Now we simply going to creating our functional API or functional model. So there is no sequential model. So you need to pass here the data into one layer to the another layer as a functional way. Okay, that's mean from layer to I'm going to pass this layer to the another layer, and this output will go to the another layer like this one. Okay, let's say I have first layer output I got here. Let's say 12. Then I'm going to pass this 12 inside my next layer. Okay, this is how the functional actually works. Okay, there, that's it. Okay, so now what I can do, I am simply going to using here my conm2d, just like the image classification tags. Then I'm going to give here my filter size. So let's say filters. Okay, filter or filters. Let's give here 64 filters, and having the kernel size. Let's give it the kernel size, not Keras, okay, kernel size. And I'm going to give here my kernel size should be 3. Then I'm going to give here the stride. Let's say stride. So orthotion aata hai nahi. It's not orthotion is not coming. Strides, and strides is equal to let's say 2,2. Sorry for this bullshit types of sound. Maybe it's happening here because I'm right now at home. So padding equal to same. Let's make it same. Then I'm going to pass this discriminator input inside my conm2d. So for that, what I can do, I'm simply going to pass this dict input inside my convolution layer. Okay, now this is nothing but my one output. See one thing here, this is my input. Now this input, it will go to the convolution layer, then I can get here one output. Now this output will pass inside my next layer. So next layer is nothing but my activation function. This is my leaky relu, and what I can do, I am simply going to pass it this leaky relu. Simple. And again, let's make it X. Simple, just like that. You can creating one functional model. Then again, I'm going to give here the dropout. Yes, dropout तो needed है. Okay, let's say dropout देना पड़ेगा. Dropout दे दिया यहाँ पर. Okay, let's copy this out, and I'm going to make one dropout so that we can deactivate it some of the neuron. Let's give here 20% of the neuron should be deactivated. Then let's X. So this is how you can actually creating one functional model. Okay, so see, we know that discriminator is nothing but one a classification types of actually uh, a model. So its work is to classify them which one is a real or fake. Okay. So now what I can do, I'm simply going to copy this out x, and I'm going to paste it here. Okay, and try to change the filter size, and it have a 64. Let's make it is 128, and it having a kernel size of 3, style should be 3, padding should be the same. Passing here my this should be the x. Okay, this should be x. Just you're going to passing this x into the same convolution layer. Let's copy this out again, and then what I can do, I'm simply going to pass it here, and let's make it 128, filter size 128, kernel size 3, start equal to 2 cross 2, and padding is the same as it is, okay. Then simply going to make it 64. This is just for one classification task. You can play with them. It having also architecture. But when you go to the deeper, we are trying to taking one architecture from the peppers and try to building this model. It's also I actually get this model architecture inside on peppers. So don't worry, I'll put this link, pepper links inside the descriptions. Then you can actually do that. This kernel size, how many filters are showing up. Just I'm going to classify them, right? Now what I can do, I am simply going to make it 64. Then after that, at the last layer, I need to also do the flatten. Okay, so that I'm going to convert them into the one single vector. So for that, I'm going to using here the x equal to, I need to also import it here. So in flatten is also available inside my layers. So flatten, aja, flatten aa gaya yahan par. So flatten, and I'm going to pass here flatten layer, flatten to be inside x. Okay, okay, I need to also pass this outside that. Okay, because this is nothing but one instance, so I need to make in this way, not like this way. थोड़ा थोड़ा तो mistake हो जाता है ना. This is how you're going to pass the one value to the another value as the functional models. Okay, now I need to give here the classification layer, which one is the nothing but my dance layer, is nothing but this image is real or fake. So that's why I need to give here the dance layer. I need to also import it here. That's a dance. Okay, that's it, dance. Okay, that's it. Now it's dance layer. Then I'm going to pass here my classification. That's one, because this is nothing but just one class. It will give me at a time. So this is real or fake, just one class. Then I'm going to pass here my x also. Then after that, I can get here my output. It's my output layer. So for the output layer, I'm going to using here my activations as sigmoid. So for that, I have to also import here the activations. So let's say activations, activation. Okay, activations, so that you can also using here the activation functions. Okay, so you can also pass here just like the activation, and inside as you can pass here the leaky rail also, but you can import it like that. So let's say activations, and inside the activation, I'm going to pass here my sigmoid, because this is just one binary type of classification. So that's why I'm going to pass the sigmoid. Otherwise, it have the multi-class, and to pass here as a softmax. Okay, that's my architecture of the discriminator. Now what I can do, I am simply going to pass it inside my model, so that we already imported here. And if I try to check that inputs equal to discriminator, let's say this is my discriminator. Which one is it? Input, discriminator input, and the input I'm going to passing here by discriminator input. Then for outputs, and I'm going to pass here my output, just it output here is it. Now let's assign into the variable that's called the model. Okay, let's say disc model. Okay, disc. Okay, like the discriminator. Then I'm simply going to return it here. Let's say return the disc. Okay, that's it. So our discriminator model is ready. So if I try to call it one, let's try to check this out. It's working or not. Okay, I'm going to call it here. Okay, it's not con2d. Okay, con or conp. Oh shit, it's con2d. Okay, I need to copy this out again. थोड़ा थोड़ा मिस्टेक तो हो जाता है ना, इसका बाद यहाँ पर दे दूँ. Okay, let's tag this now. Okay, this is my one functional model. You can see here Keras engine dot functional. Doesn't mean this is nothing but functional types of models. So if I try to assign it inside the model and try to check the summary, let's try to that. I can get the summary of not. So let's say summary. Okay, I can get here summary. Okay, that's it, summary. Okay, so this is nothing but a summary of my discriminator. See how many total parameter, how many trainable parameter actually available here. And also you can see the activation functions, dance layer, the leaky rail, all of them actually happening here. So this is how you can actually creating one discriminator model. Now let's try to creating one generator model. So generator is taking some latent vector or random noises. So let's make it def generator model. Okay. Now simply we need to also give here the input and also give here my input shape. So input shape. So this is nothing but one shape. So shape is nothing but some latent type of vector. So for that, what I can do is simply going to give here one input parameter. By default, let's give here z equal to let's say z dimensions equal. Let's give here 100. Okay, what I can do, I'm simply going to pass it. It's by default. Okay, by default parameters. Then I'm going to pass here my names. Let's take names. Just take to do it in the generator also. You can see here the discriminator network. So let's make it the, you can see here discriminator network also showing up here, the input layer name. So let's make it generator network like this one. Okay, so our input shape is ready with having the 100 of latent vector. So let's make it gen input or generator input. Now what I can do is simply going to pass here. We're simply going to pass here my dance layer, fast dance layer. So fast dance layer, actually what I can do, it will creating some noises. It is creating some noises or latent vector. So how can I creating the noises? Using the dance layer. So dance layer. So what I can do, we can simply going to pass here the noise of 8 comma 8 comma 8 into 8 into 3. I mean 8 cross 3, nothing but my width, height, and the channels. And now I'm going to pass it inside to my in gen input. Just it. That's how you can creating the latent vector. So let's say x equal to dance 8 cross 3. This is about my research paper. In the research paper, it actually mentioned that the target size also. So now what I can do is simply going to reshape it. See, just one thing. If I'm trying to copy this out and try to paste it here, see, this is nothing but one dance layer. Okay, this is nothing but one dance layer. So what can we do? What can we do actually? We can simply, let's try to copy this out also. Copy this out also. Pass it here, and I'm going to pass here my input. See one thing here. Okay, z dimension is not defined. Let's say give it 100. So what it can do, it can creating one Keras tensor. See, it can creating one Keras tensor with having the shape of 192 latent vector. 192 latent vector. Now using this, we can also do it reshaping. We can reshaping with the 8 cross 8 cross 3. Reshaping means क्यों भाई? क्यों? क्योंकि यहाँ पर सेम टाइप्स ऑफ इनपुट शेप मुझे देना है. सो इनपुट शेप तो ऑब्वियसली विथ हाइट और चैनल में देना है ना, इसलिए. ओके, नाउ व्हाट आई कैन डू इज सिंपली गोइंग टू pass it inside the reshape. So you need to also mention it here. Here is it, reshape किधर गया? यहाँ पर इसका नीचे आन दो. Okay, let's make it reshape आ जाएगा. Okay, reshape. Okay, reshape. Okay, done. Let's run it now. Okay, reshape. Okay, now inside this reshape, what I can do is simply going to pass my target shape. So target shape. Okay, target shape aa ja, target shape. So let's make the target shape 8 comma 8 comma 3 with height and the number of channels. And simply I'm going to pass here my x, just like we do in the functional. Okay, let's make it now. Okay, let's go. Now what I can do, after reshaping, we're going to do the batch normalizations. Batch normalization. It is based on my peppers. Okay, normalizations. Batch normalization. We need to also import it. So if I see here, batch normalization, if I see it here, we already imported not. Okay, surrounding the parenthesis, I need to make it inside that like this one. Okay, now, okay, imported, no error. So batch normalization is also imported here. Let's try to make it the batch normalizations. Then what I can do, I am simply going to passing my x also. That's x. This is how you can creating some fake images. Okay, that's it. Now what I can do, I am simply going to give here my leaky relu as an activation function. So let's use here the leaky relu, and I'm going to pass here my x. That's it. So first layer is completed. Now what I can do, I am simply going to use my deconvolution neural network. So if I go on the picture again, so let's go on here. You can see here this is nothing but one deconvolutional neural network. So we create our random noises. Now we're going to pass in these random noises inside the deconvolution neural network. Okay. So for that, what I need to do, I need to create in here the con2D transpose. Okay. If I go on here, just going to import it. That's better. I can copy this out. Okay. So that I don't need to go it here again and again. Okay. Let's go on here and try to import it. And I'm going to use here that conf2D transpose. Conf2D, if I use the tab, you can see here conf2D transpose. So conf2D transpose is the opposite of the convolution neural network. Opposite of the convolution neural network. So what I can do is simply going to using this convolution 2D transpose. So con2D transpose, and inside that I'm going to pass here my filter. See, in the classification network, it starts from the little one and a small number of filter. But when you're using here the con2D transpose, I mean the deconvolution neural network, the filter size should be bigger, and after that it will go into a small. Then I'm going to make it the kernel size. So let's say kernel size, kernel size equal to, let's give here 3, and giving here the stride, let's say stride, okay, stride, let's give here stride 1x1, and I'm going to give here the padding should be the same. No padding, I don't need it. Okay, then I'm going to pass in here my x. Simple. That's also imported in the x. Now we're going to using here one batch normalizations. Okay, let's use it. Let's use one batch normalizations. Batch normalization, normalization. Okay. और यहाँ पर शायद import में गलती हुआ है. Normalizations, batch normalizations हो गया. Okay, batch normalization imported. Now what I can do, I am simply going to pass my x also. That's x. Okay, that's fine. Okay, यहाँ पर क्यों आ गया भाई? Okay, and then I am going to make it inside the x here. Okay, fine. Now let's put it inside the x. Okay, fine. Batch normalization and pass the inside the batch normalization. Then we're going to using here one leaky relu. Copy this out. Copy करते हैं. Okay. Okay. Transpose ले तो हो गया. इसके बाद क्या करेंगे? इससे copy करेंगे. Paste करेंगे. Okay. So let's try to make it out. 256. We're working based on the peppers. 256, then 128, then again you can also play with them. Okay, play with the kernels. 128, and what I can do after that, I'm going to making this filter size should be the 2,2 stride 2,2 based on the peppers. Okay, this is how you can actually building one GANs architecture from the peppers. They actually mentioned about inside the peppers. Now after that, I need to also making this should be 2 and 2. 2 and 2. So that's been in first layer it having the stride of the 1,1, the second layer it having the stride of the 2,2, and again it having the 1,1, and again it having the 1,1 and 1,1. Simple as it is. So I'm going to copy this out and to copy this out 128 filters, and I'm going to make it 128, then I having the 64. Okay, 64. That's like that. Same here, 64, 128, and 64 like this way. I mean the filter size should be the same. Okay, last one 64, and kernel size should be the 3, and after that I'm going to making should be the 1,1. Okay, so this is nothing but my 64 layer. Now I need to giving here one layer with having the 3 channels. Okay, that's it. See, just need to remember this thing here. Just make it 3, and kernel size is 3, and padding is also 1,1, and padding make it same, and it don't having the batch normalization in the last layer. See, again here in the first layer it having the filter of the 512, kernel size is 3, stride is 1,1, padding is same, and the next layer it having the stride of the 2, and all of the are the same. In second layer it having the 128 filters with a stride of 1, and again in the last layer, in the last of the 128, it having the stride of the 2, then we having the filter of the 64, the stride of the 1,1, and the filter size is nothing but 3, and the stride is 1,1, kernel size also 3, same as it is. Then what I can do is simply going to remove this batch normalization in the last layer. Then what I can do is simply go do the same thing that we do earlier in order to building one model. Just I'm going to copy this out, and I'm going to using here. Okay, inside this input I'm going to pass here my GAN input, I mean my generator input, and the output I'm going to passing here my images. Okay, so images is nothing but my leaky yellow. Let's make it images, because after that when you try to do this deconvolution operation, after that you can get here some fake images. Let's make it fake images. Fake images. Okay, fake images, let's say generator, like that. Fake images gen, and I'm going to pass in here outputs. Then after that I'm going to return here my model. So which model is nothing but my gen model. Gen or let's make it model gen. Okay, like this one. Okay, then I'm going to simply going to import my model. That's it, that's it, that's it, simple. Okay, I'm going to run it out. Okay, fine. Let's going to call it out here, generator model. And if I'm trying to make it inside one variable, let's call the, if I go up, see, this is nothing but the model. So let's make it dix model, and let's make it dix model. Okay, so that name should be very. Let's make in gen model. Okay, okay, it having some problem. So let's go on here. What kind of problem? Keyword argument not understood, call stride. Oh, it strides. थोड़ा मिस्टेक हो जाता है. हो गई अब. Now let's try to see the gen model. I mean generator model. That's a summary. Okay, so you can see here the generator network is my name, and it having, see, you can see the how many total number of parameters, and trainable parameter and the non-trainable parameters. So we can build our generator model and also the discriminator model. Now what I can do is simply going to call it out here. Simply going to call it out here. So how can I call them? Let's say I'm going to calling here first the discriminator model. Let's make it discriminator model, and after that I'm going to call my generator model. That's this one, generator model. That's it, and this one, and I'm going to give you the same name that we actually give the earlier. So let's give here the discriminator model as we keep earlier. That's a dix model, and we have the generator model. It's called gen model. Gen model, this one. Okay. Okay, we initialize our discriminator and the generator. Now what I can do is simply going to compile the train discriminator. See, so how you're trying to training the discriminator, the generator is skip. Okay, discriminator is trying to checking them. How you generate the images, discriminator should be skip, like this way. So now what I can do is simply going to compile the model that train discriminator. Okay, trains the discriminator. So then what I can do, now I'm going to compile the discriminator model. So let's try to compile the discriminator model. So discriminator work is to classify them. It's nothing but one classification types of model. Compile. Now I'm going to give here my optimizer. So optimizer kya diya? Let's give here Adam optimizer. Then I'm going to give here my loss. So loss is binary cross entropy, because this is nothing but one binary types of classification, real or fake. So let's give here binary cross entropy. Then I'm going to give here my matrix. Obviously matrix should be the accuracy matrix. तो हम जानते हैं. Okay, fine, accuracy matrices. Now what I can do is simply going to run it here. So our discriminator model is compiled. If I show it, see it, it's on functional model, that's like that. Now what I can do, we compile our model correctly. Now we need to compile the train generator also. To compile the trains generator also. Trains generator. Okay. Now what I can do, you can give here the input dimensions. You can see here the latent vector. We by default we pass here our jet dimension should be the 100. You can pass it here. But when you are compiling in model, the compiling or fitting your model, the discriminator, the making this generator model should be the false. Okay, making this discriminator model should be the false. When you're trying to training your generator, first thing first, it will actually compile the discriminator model, and then it can, how you going to train your generator, you have to make your discriminator model should be false. See, just see. trainable, trainable, maker the false. हो गया ना? False. Now what I can do, I am simply going to creating one input of that. Creating one input shape that we do earlier in also our model file. Here is it. Okay. So you can also copy this out. Input shape. So क्या करेंगे यहाँ पर input shape दे दो. So let's also need to also initialize here my jet dimensions. Jet dimension, let's make it 100 as it is we do earlier. So name is nothing but my model input. So this is nothing but my model input. Which type of model is nothing but my combined model. It's nothing but my combined model. So now what I can do is simply going to pass it inside my discriminator model. So let's make it discriminator model. And inside that, I'm going to call my GAN model too. So GAN model, and I'm going to pass here my model input. So that's my model input. Model see by क्या हो रहा है यहाँ पर देखो I'm passing here my model input. See, first you're going to creating here compile our training discriminator. Discriminator tracks is to try to do the US classification. Okay, it's working like CNN. Okay, the convolution neural network. So after that, we are going to creating one Latin vector, Latin shape input. Then what I can do is simply going to passing my output. Okay, I mean input inside my discriminator, and discriminator try to check that which one is a real and which one is a fake, which one is real and which one fake. So in once time, generator is trying to fool them that it is a real images, and this is how the fake images is generated. Now what I can do, this is my mathematical model output. देखो भाई कैसे बुद्धू बना देते हैं यहाँ पर, क्या बोलते हैं ना जनरेटर डिस्क्रिमिनेटर को. Okay, हो गया. Now what I can do is simply going to pass it into model. That's my combined model. So model में pass कर दो भाई. So model में क्या होगा, मेरा model के input होगा, इसके बाद model का output. Simple. पास कर दिया. Okay. Model equal to model के input, model का output. इसके बाद क्या करेंगे, compile करेंगे. Let's make the compile. Compile कर दो. Compile क्या होगा, same thing भाई, same thing. Here is it. Just check here. हो गया. Okay, if you're trying to check the model summary, आता है और नहीं आता, देखते हैं. आगे हमारा इनपुट देखो. ओके, हो गया. हमारा मॉडल का नाम है मॉडल इनपुट. यहाँ पर है फंक्शनल टू मॉडल, वन है जनरेटर, अनदर है डिस्क्रिमिनेटर. इसके बाद आउटपुट आएगा वन, फेक इमेजेस आएगा. Okay, fake images आएगा. Now what I can do is simply going to creating one function which can actually help us to taking some Latin vector and try to pass here one batch of the images. Okay, so for that what I can do, we're going to define here two functions which can actually help us to train the discriminator and also help us to train the generator and also try to save the images inside my folder. So for that what I can do is simply going to creating some valid and the fake images using the numpy. So for that I'm going to using here my def train. That's a def train discriminator. इसके बाद क्या होगा भाई, यहाँ पर देना पड़ेगा बैच दे दिया, PATCH बैच दे दिया. इसके बाद देना पड़ेगा बैच साइज. सो बैच साइज देना पड़ेगा, बैच साइज हो गया. Then what I can do, you can do creating two variable. That's called valid and another one is called the fake. हो गया. So valid image क्या है, np.once का. Okay, np.once का for checking purposes. Okay, you can just checking for this, for the checking purpose we can actually using here the train discriminator and train generator. Just going to passing here some Latin vector with having the valid of the ones and fake of the zeros. काला होगा ना. So now what I can do, I'm simply going to passing my batch size. इसका pass करते one. Okay, so let's going to copy this out also and let's going to make it zeros. Okay, batch size I'm going to pass it here one. तो इसके बाद क्या होगा, हमारा जो ट्रेनिंग है ना मॉडल, वो ट्रेनिंग हो जाएगा. सो डिस्क्रिमिनेटर मॉडल इसके बाद क्या होगा, ट्रेन ऑन बैच अगर जाएगा. नाउ आई एम मेकिंग हियर बैच and I'm going to pass here my ballot. So train ho jayega. Now what I can do, train on generated images. So for that, I'm going to creating some noise. So let's say noise equal to np dot random. इसके बाद let's say taking the normal noise, normal distribution types of noise, passing from 0 to 1 and giving here a bass size, and I'm going to give here my jet dimensions. So because we have passed the jet dimension of the 100, so that's why creating here the noises. So this valid and fake actually giving here the discriminator model train on the basses, that how many basses of the images it will be coming up. So when you're training up that, you can actually see it earlier. Okay. Now what I can do is simply going to pass this noise inside my generator. So let's call gen model dot predict. Then I'm going to pass him a noise. So देखते हैं हमारा generator क्या output देता है. Let's call gen images. It's generated the images. Then again discriminator model train on batch. Then I'm going to passing him a gen images. Gen images. Then I'm going to passing her fake images. So this is how the train discriminator actually work. Okay, simply have the valid images, we have the fake images, discriminator, and discriminator you're going to making one batch of the images or the batch of the batch size, that how many images that you're going to taking, and after that you're going to creating here some noises, and after that you're going to creating one model or images using this GAN model, and after that we're going to checking that. Okay, so that we can actually save it inside my directory, because this discriminator model actually generated some images. Then after that we're going to save it inside my folder. Now I have to same things I need to do it to creating one generator, train generator. Okay, train generator, it will taking one batch size, it's not taking the batch size, and it having the valid and having the noise, just having the valid, because generator is just taking the valid images, and after that it will actually trying to actually generate some fake images. So noises, the same thing as it is, we creating the noises with the dimensions, and after that you're going to using here the model training. So what I can do is simply going to remove it. So after that what I can do is simply going to using here a model that you created, you can see here this whole model, and I'm going to using here train and batch. I'm going to pass here my noise, and I'm going to pass here my valid. So this is how you can actually using here the train generator and the train discriminator. Okay, so our function is loaded. So now we need to creating here two functions to saving the images and also saving for the generator. So for that what I can do is simply going to using this def the save images. थोड़ा शायद बोरिंग फील होगा. Images के बाद देना पड़ेगा path. Then what I can do is simply going to using the tf.keras dot preprocessing dot image dot array to image, and going to make this fake images to the real images, because this is nothing but one Latin vector. So fake images, and I'm going to making with numpy array. Okay. Then let's save it inside the variable. Let's call the images. Let's call images, or let's say call image. That's it. Now I'm going to save it inside my directory. So let's say tf dot keras dot preprocessing dot image dot save img, and I'm going to passing here my path and also my images. Which path you're going to giving, based on the path it actually saving the images. Okay, images, and after that I'm going to return the image. Well, now I'm going to also creating one function which one is going to save it inside my generate and save images. Let's say and save images and save images, and I'm going to passing here my path, and after that I'm going to creating the noises, the Latin vector noises. So that's a noise. इसके बाद np.random that you actually do earlier. Just copy this out here. I'm going to copy this out, the same thing as it is, and just having the normal, and batch size should be the one. In one single batch size, it will generate some one images. Okay, one batch, after one batch it will generate one images. Now what I can do, I am simply going to creating one fake images directory, and I'm going to creating here my GAN model for using the generator model, and I'm going to passing him a noise, and after that I'm going to save it my images. So image equal to save image, the same image functions, and inside that I'm going to passing here my fake images. I mean these fake images, the first one, let's make it out, and I'm going to passing here my path. Okay, that's mean inside this generator and save, it will generate the images and also saving the images inside my directory. Now inside that I'm going to show the images inside my Jupyter notebook. Okay, then after that I'm going to show you the plt.imshow. So imshow, then what I can do, I'm going to passing here my images and simply going to plt.show. That's it, plt.show. Okay, so our function, this function is also ready. Now what I can do is simply going to train it our model. So for that what I can do is simply going to creating one loop. So let's say epochs in range, let's give here 10 epochs. Okay, 10 epochs. You can also increase it, let 50 or 100, but later on how you actually trying to train it, you're going to using here the Google Colab, because I don't have the much more amount of GPU also. So it's better I can also run it in the Google Colab, and after that I can also show the output. So now let's try to print it, that how many epochs is actually happening. Let's see epochs. Okay, epochs. So you can also using here the f string also. Let's also use it so that it can looks better. Here is it. So we need to pass it inside the curly brackets. So curly brackets में डाल दो. So number of epochs. Okay, like this way. Now I need to creating the batch size also. So let's say I comma batch. So in enumerate, and I'm going to passing here my epochs, and epochs or dataset. I need to passing here my dataset inside my dataset. Okay, this dataset that I actually load earlier. Okay, here is it, this dataset. Okay, fine. Now after that what I can do is simply going to enumerate here with the batch size. We should pass here batch size is 128. Now after that we get here the index number and also the batch size of the images. So what I can do is simply going to enumerate it. Now we're going to calling here our train discriminator, that our discriminator, this function is called the train discriminator, and I'm going to passing here my batch. So my batch is nothing but my batch, and my batch size is nothing but my batch size dot shape. This batch size dot shape, batch dot shape of 0. Okay, this batch is coming from a data set that actually initialize it here. You can see this batch size 128, the shape of the batch size. Okay, that's fine. Then after that we're going to calling here our also train generator. So train generator, and after that I'm going to passing here my batch dot shape, then we have the 0. Okay, fine. Now after the 20, after 200 epochs, 200 times the 200 images, what I can do, it can going to save one images of the batch size. So let's say if the I is modulus 200 equal to 0, after 200 we're going to taking on the batch of the images, or you can also make it, let's give it 10. After 10 of the base images we can taking the one batch or one complete batch of the images. So we can also using here the generate and the generate and the save image path that actually show earlier here. So let's make it 100. Okay, now what I can do is simply going to printing. You can also print the batch size and how many batches are actually happening, so you can also show it out. So let's call batch, and you have the batch number. So batch number is nothing but coming from the I. So this is nothing but batch numbers. We can also using here the f string. So let's say batch, that how many batch of the images are actually loaded, batch images. Okay, so we can using inside the curly brackets. Simple. Now what I can do is simply going to give here the path of my directory, in which path I'm going to actually save my images. So I'm going to using this generate and the save, and I'm going to give here my paths. Okay, so for that what I can do is simply need to go inside my directory, GAN space. Let's say I'm going to create here one folder that's called generate face. That's it. So I'm going to copy this path and go inside my here, and that's going to paste it here, generate face. Okay, this is nothing but a path of the images. Let's call path equal to generate face. This inside this path, I am going to storing all the images inside the generate path. So what should be the image name? So not also give here an image name so that it's look better. So inside that, I'm going to give here also using one f string. So let's give here f and f string, and inside that I'm going to using here my path. So my path is nothing but my generate face. So let's try to initialize it inside one variable. It's called the path. Okay, caps lock देते हैं path, and this is my path. Generate face. That's it. Now what I'm going to do, I'm simply going to passing here my path, and inside this path I have the all images with epochs number. So that's epochs, and I need to also using here the bash. I mean which bash of the images it actually storing. So I need to give here my bash size. So that's the bash size or epochs. Let's keep here the epochs. This epochs actually, this epochs, and I'm also giving here the batch. That's a batch. Which batch is this? Then I'm going to convert them into the JPG. Epochs. Then I have the path. Then I have the batch. So this is how you can actually saving the images. So now if I'm trying to run it out, okay, invalid syntax. Okay, I think having some invalid syntax. It should be the epochs. Okay, let's try to make it out like this way. Okay, it having some, okay, number of epochs, 8 epochs. Okay, number of epochs, here is it. Okay, we having some, okay, epochs तो इधर देना है ना इसका अंदर. Okay, sorry, थोड़ा mistake हो जाता है ना यहाँ पर. Okay, batch images, again batch images. Yep, either I should have doing this same things again. Okay, fine, let's run it down. You can see number epochs, batch is not different. Again batch तो यानी इसको स्टॉप हो जाता है. batch is not defined. किधर गया batch? This batch. Okay, so number of epochs is right now 0. You can see here epochs is starting, but GAN images is not defined. GAN images is not defined. किधर गया? GAN images is not defined. GAN images. There should be the problem of the actually images. Yes, here it is. और किधर है और किधर GAN image? Okay, let's देखते हैं. थोड़ा mistake हो जाएगा यहाँ पर. Okay, number of epochs is 0. Yes, it will take so amount of time when you're trying to creating one image. Okay, fake images is not defined again. किधर गया भाई, किधर गया? Okay, इस images is image. थोड़ा mistake हो जाता है यहाँ पर. So let's try to check this out. यार किया किधर गया, किधर fake images, इसको fake images बोलता है इसको. Okay, again let's check this out now. So थोड़ा mistake यहाँ पर हो जाता है ना alphabet वाला. So this is how you can see here one batch of the images is generated, batch images, and after that it will actually generate another batch of images. It's nothing but one latent vector. So this is how it can actually generate some fake images, and after a few images, I mean a few batch of the image epochs, it will try to creating some fake images. So now what I can do is simply going to creating our Google Colab and try to upload our data set inside that. Then what I can do, we can going to training it out in the Google Colab and try to check that how many images, I mean which kind of fake images that actually we are able to generate. Okay, so now इसको मुझे यहाँ पर स्टॉप करना पड़ेगा, नहीं तो मेरा पीसी जो है ना वो चला जाएगा सर में. Okay, so now let's go on the Google Colab and try to check that how can you actually train it out in the Google Colab and also try to generate some fake images. Okay, local PC में try मत करना, नहीं तो PC crash हो जाएगा. Okay, let's go on the Google Colab now. So well, you can see here, upload here my data set in a zip file. I'm just going to create one zip file of that and upload it inside my Google Drive. So now what I can do, I'm simply going to paste here my code and then just upload here my notebook, my Jupyter notebook, and I just add here 2 lines. First line is nothing but for mounting my Google Drive, and second line is nothing but my unzipping the file. You can see here, this is nothing but one file that's called the image align celiba.zip. I am just simply going to unzip it using this command. So exclamatory sign unzip, and you have to give here your path of your data set, I will zip file. And after that, inside this GAN, I'm going to simply going to extract in the file. So what I can do, I'm simply going to uncomment this, and also make sure that if I go on the runtime and change runtime type, I need to select here GPU. Okay, so click on OK and click on save. So it will actually creating this file, I mean running this file inside the GPU, so that our training process is uh, quite fast. Okay, so now what I can do, I'm simply going to click here to um, mount the Google Drive. Just going to connect to Google Drive here, and I'm going to select to choose my Google account, and after that I'm going to access my image folder. So if I go on here and try to refresh it, and you can see just white. Okay, Google Drive is mounted. If I go on my drive and inside my GANs folder, you can see here my file is here. You can see the zip files and also the unzip one. So it will take maybe 20 to 30 minutes to unzip the file, because it have the 2 lakhs images, quite big amount of data set. That's why I skip the unzipping process. Just you need to pass here this kind of uh, command in order to unzipping the file. So now what I'm going to do, I'm simply going to go down. All the codes are same. You can see here inside this image align, it have another images folder. I'm going to copy this path here, and I'm going to simply going to paste it here. Okay, just paste it here. Simple. So now simply going to run on the shell. Just run it, and I'm going to also run it here, the directory, and also the grid of images, and also the iterator, so that it can start the training process. Okay. So if I go on here, you can see it will load in the data set from a directory and try to do the normalization of the data. Okay, let's run all of the shell. And I need to also do some changes on my uh, discriminator and the generator, I mean for saving purpose. Okay, at the last. Okay, so you can see here to generate the faces. That's fine. So to give here also the path. So what I can do, I simply going to go on my drive, and I'm going to creating a folder that's called the generate faces. Okay, किधर गया? It's running. Okay, it's quite taking time because it's loading the file from the directory to Lux file. So obviously it take time. Okay, let's go on here inside the drive. Okay, refresh करते हैं क्योंकि टाइम लेते हैं ना, बहुत सारा फाइल है इसलिए. So now what I can do, I simply going to create here a folder that's called the generate phase inside this GANs folder, so that my generated images should be saved inside my folder. So new folder, let's give here one name. Well, I need to give here my file folder name. Let's call generate phases. So well, it is also created here the folder that's called the generate phase. So I'm going to simply going to copy the path here and try to add here the path, so that inside this path my all the images that is generated using the GAN is saved inside this folder. So I'm simply going to run this shell also. Okay, so to run in the shell also. So after the training process is completed, then I'm going to show you that how the file is generated, I mean the faces, fake images. So I'm going to pause the video here right now because it's take much more amount of time. So well, you can see here the file are generated, images are generated. You can see here this is with the latent vector, and also you can see here after 3 or 4 epochs, and you can see image is quite just like the skin colors. That's me trying to generate the images. Okay, using this latent vector. Okay, so this is how it actually generates the images, fake images. So if I go inside my Google Drive, and you can see just to wait. Okay, here is it. You can see here the images is also stored inside my generate faces. So now what I'm going to do, I'm simply going to run it for the 15 epochs in the later on. So you can see I just give here the 10 epochs, but it will take some more amount of time. Okay, so if I go up here, just see here is it. Where is it? Yep. Yep, I gave here the 10 epochs. So better you can run it for the 100 epochs or the 50 epochs. Maybe it will take 3 to 4 hours to training it out. So this is how you can actually generating some fake images using the generative adversarial network. So after 14 epochs, it will take 3 to 4 hours in order to training the model with the GPUs. And I got the final output just like that. It's also, you can see here, it's trying to creating the images of the human faces. So it's just nothing but one architecture of the GAN, that how the GAN architecture actually look like. But in the next few tutorial, we're trying to creating one DC GANs or conditional GANs. So in this case, if your images it looks like the realistic, and your features of the images it looks better than this now. Okay, these images. So that's it for today now. Hope you enjoy this tutorial, and make sure to subscribe to the channels, share with your friend, family, even your boyfriend and girlfriend. So thank you and bye bye. And I'll be back with the another tutorial. So till then, take care and bye bye.